Hello, my friends. Thank you very much for subscribing to our channel. A, B, C are three integers, where a is bigger than 0, but smaller than the cube of b. A plus the cube of b is equal to the cube of c. So, what is the minimum value of b plus c? Why not give a try, and we will come back soon. A is bigger than 0. Then as an integer, a cannot be smaller than 1. The cube of c is equal to the cube of b plus an integer that is not smaller than 1. Then the cube of c must be bigger than the cube of b. C is then bigger than b. As an integer, c cannot be smaller than b plus 1 then. What does this mean? This means that, if b has a minimum value, the minimum value of c will be the minimum value of b plus 1, and if both b and c reach their minimum values at the same time, then the minimum value of b plus c is the summation of their minimum values. So our task now is to check if b and c can reach their minimum values at the same time, and what their minimum values are. Let's get back to a plus the cube of b is equal to the cube of c. Because a is smaller than the cube of b, so if we replace a by the cube of b, we will get that, twice the cube of b is bigger than the cube of c. Bringing here that, c is not smaller than b plus 1, we have, twice the cube of b is bigger than the cube of b plus 1. The cube root of 2 times b is therefore bigger than b plus 1. So b is bigger than 1 over the cube root of 2 minus 1. This number is approximately 3.85. So the minimum value of the integer b is 4. And the minimum value of b plus c is 9. There is a small problem though, that the value of 1 over the cube root of 2 minus 1, is in fact not that easy to find. But it doesn't matter too much, even if we don't know how big it is. Because we only need to know, and have known that, when b is bigger than a certain value, we can get twice the cube of b bigger than the cube of b plus 1. And b is an integer, so we can try it one by one from a relatively small b. We will not try 1, because the cube of 1 is still 1, which cannot fulfill the requirement of being bigger than another positive integer a. When b is equal to 2, twice the cube of b is equal to 16. And the cube of b plus 1 is equal to 27. Not work. When b is equal to 3, twice the cube of b is equal to 54. And the cube of b plus 1 is equal to 64. Not work either. When b equals 4, the cube of twice b equals 128. And the cube of b plus 1 equals 125. So 4 is the first integer b that fulfills the requirement. In this case, c is equal to b plus 1, which is equal to 5. And a is equal to 125 minus 64, which is equal to 61. Thank you for watching, and see you next time.